Okay, today we're looking at distances on the Earth. So there's two lessons in this series. We're going to look at great circles and we're going to look at small circles. So we'll start off by looking at the difference between great and small circles so that you understand that. And then the rest of this lesson will focus on the angular distance between coordinates and calculating the distance in kilometres using that angular distance between two coordinates. So a great circle is the largest circle that can be formed on the Earth's surface. So basically the equator is one great circle, and then we have our meridians. Now, your meridians are your lines of longitude that go around the Earth this way and through the poles. So they each run through the North and South Pole, effectively cutting the Earth neatly in half. They are the largest circle that can be made. So all of the meridians around, or lines of longitude, are all great circles, plus the equator, which is our only line of latitude that is an actual great circle. Now, they run through the two poles. They include the equator. When we look at small circles, however, you'll find they are your lines of latitude. So, except for the equator, because it does go around horizontally at the largest point of the Earth, so it is the largest one horizontally that can be made, all of the rest of these lines of latitude are small circles. And as you can see, as you move north of the equator or south of the equator, all of those lines of latitude that create circles get smaller and smaller. So they're all smaller than the great circle at the equator. So if we were to look at the circumference of a great circle, we would first of all need to understand why we've got the radius of the Earth set at 6,371 kilometres. So basically, the radius at the equator is about 6,378.14 kilometres, but the radius at the poles is only 6,356.75 kilometres. So basically, we use an average radius because it works good enough for pretty much all calculations of distance on Earth. So the average radius is 6,371 kilometres, which you can see will just pop down the bottom here. Now, the shortest distance between 2 points is a straight line, but we can't actually tunnel through the Earth. So if we've got this circle along here, we can't actually go from this point to this point and just tunnel straight through. If we had a point at this point and then a point here, the shortest distance would be a line straight through like that, but we can't actually dig a tunnel under the Earth. So the shortest distance will always go along a great circle. So that from this point to this point, we'll go on that curvature. So it will be the arc, the curve following a great circle route. So points that lie on the same meridian, which are lines of longitude, are basically on the same great circle. And what we do to work that out, to work out the rule, what we sort of need to look at is the fact that the circumference is equal to 2 pi r. Now we know that rule. 2 pi r is how we figure out the circumference of any circle. And so if we look at the information we have, that's 2 lots of pi multiplied by our radius over here, 6,371. And if we multiply that, we end up with about 40,030 kilometres. Now, if we just have a quick look, we'll see that with this working, this is our K1, this is our K2, this is our K3, and this here is C1, just stating our units. So just a reminder of our criteria. So, therefore, what this means is if 360 degrees, and so that's the entire great circle. So if the radius is 6,371 kilometres, then 360 degrees of the Earth is equal to 40,030 kilometres. So 1 degree is going to equal, basically what we need to do is we need to divide 40,030 and divide it by 360. So if we do that, we end up with about 111.2 kilometres. And so that is the rule that we're going to use. So I guess really we're going to put 1 degree is equal to 111.2 kilometres on a great circle. Okay? This is something you should definitely ensure you have written down. It is a rule that you would like to remember. Okay, so now we look at actually calculating distances on the great circles. So the distances between points on the same meridian, meaning that they're on the same great circle or line of longitude, we can do that by calculating the angular distance. And the angular distance is the difference in latitudes. Now there's a couple of little nifty rules to remember, which I suggest you write down. So basically, looking at the difference between latitudes, if our latitudes are on the same side of the equator, so that means that both latitudes are north or both latitudes are south, then we subtract to find the difference. However, if they are actually on opposite sides, so that means that one is north and one is south, or south and north, but if they are on different sides of the equator, then we actually add them to find the difference. So for example, if we had, say we had 65 degrees north and 20 degrees north. So these were our two latitude measurements. So to find the difference, it's a bit squeaky today. So difference in latitude is going to be 65. And we're going to, we're going to subtract those because they are both north. So 65 minus 20 degrees. So that's going to be 45 degrees. So that would be our difference in latitude for this one. Now if we had, say we had 28 degrees south and 40 degrees north. Now this time, because we actually have them on different sides of the equator, we're going to add those to find the difference, which is a little bit counterintuitive, but that's what we're going to do. So we'll have 28 degrees plus 40 degrees. So that's going to give us 68 degrees. So 68 degrees would be our difference in latitude. Okay, we are looking for the shortest difference in latitude. And I guess lastly, we just need to remember that difference in latitudes is the angular distance. Okay, so the angular distance here is 45 degrees, the same as the difference in latitude. And angular distance, squish it in here, is 68 degrees. Now, basically what we do with that, if I just move this up a little, what we actually then do with that is we can multiply our angular distance, okay, to find the overall distance. Okay, let's just get rid of this. To find the overall distance, we multiply the angular distance by our 111.2. And that will allow us to calculate the distance between the 2 points on a great circle. So this here, again, is an important formula. Okay, so let's have a look at a bit of an example. So we're looking at P and Q as 2 points on the Earth's surface with coordinates 27 degrees north and 30 degrees west for the first point, and 39 degrees north and 30 degrees west for the second point, respectively. So respectively just means in that order. That's first point and second point. Calculate the distance between P and Q to the nearest kilometre. So straight away we know we're going to need to round our answer in order to ensure we get our C1. But the first thing I'm going to do is write my formula. Very squeaky today. So the distance is going to be the angular distance multiplied by 111.2. Now we know our angular distance is equal to the difference between the 2 points longitudinally, so we can say angular distance is equal to difference in longitude. Therefore, the angular distance is going to equal the second longitude minus the first longitude, and that's going to be 39 degrees. As you can see here, 39 and 27, so that's where I'm going to get them, minus 27 degrees, and that's going to give me 12 degrees. So, therefore, distance, my therefore is not working very well. Let's try that again. Therefore, distance is equal to 12 times 111.2. Okay, just like my formula at the top here. So I'm just putting in the value for angular distance. Now if I calculate that, I end up with 1,300. Oh, that's a terrible 3. Let's try that one again. Oh, it's not letting me. Okay, totally not letting me rub this out, so let's just scribble that out. So 1,334.4. Therefore, the distance between P and Q is 1,334 kilometres. Done. Now let's have a quick criteria check. So up here we've got our M1K1. Okay, we've got our rule. It's also telling us what we're going to be doing. And then down here we have another M1K1, because again we're looking at a sort of a subset of this rule. which is a rule or strategy in order to find angular distance. And so this one here is a K1 for sure. It's a written formula. In fact, actually, this one is probably just M1. Yeah, it is just M1. It's telling us we're going to do the difference. And then this one's our K1, the actual formula. Down here's our K2 and K3, our calculating. Don't forget that our using a degree sign in our answer is C1. And then down here we hit K1 again, where we do our formula, M1. We look at, actually, sorry, I forgot our rule was up there. So this one is K2, where we've subbed in the 12, and K3, where we have calculated. So down here I have M3, my concluding statement, and C1 for making sure I've got my nearest kilometre, you know. So the question asked to the nearest kilometre, and so I did round it to 1,334 because 0.4 being less than 5, I just round it to, I keep it the same. If this had been 0.5 or higher, I would have rounded it to 1,335 kilometres. Okay, so now we're going to have a look at the second part to this question, and that is looking at how long the journey would take in a car with an average speed of 75 kilometres per hour. Now, the easiest way to do this is to know about the triangle. Now, the triangle is like this. Oh, that's not big enough. Let's try again. The triangle has three parts. Speed, distance, and time are what we need. So speed is down here with an S, distance up the top, and time. So all you need to remember is this triangle. And the way you use it is really quite simple. Now, the best I've got is a little hand, so I will cover it. What I will point out is this line here means multiply, and this line here is a divide line. And we'll see that shortly. So basically, you cover the part of the triangle that you're trying to find. So if I was trying to find distance, I would cover the D, and that leaves me with S and T. Now, because they're beside each other, it means I multiply. So it's just speed multiplied by time, and that will give me distance. If I want to find speed, I cover speed, and I'm left with distance over time. Distance over time, like a fraction, so distance divided by time. And then the same as if I cover time, that leaves me distance over speed, so distance divided by speed. So all you need to do is remember those ones, and easy peasy formulas. So how long would this journey take tells me I'm looking for time. Oh, wrong one. I'm looking for time. And if I cover time, I've got distance over speed. So distance okay. Now, distance we just worked out. So that's 1,334 kilometres. Time, speed, sorry, is 75 kilometres an hour. Now, what's really important to note here is your speed and distance and time need to have the same units. So basically, speed needs to have the distance part of speed needs to be the same as distance. So these are both in kilometres. You couldn't have one of them in metres and the other in kilometres. They must be the same. So you need to make sure you convert the distance if need be. And then the time here will match time over here. So if this is per hour, then our time is going to be given to us in hours. Okay, they all match up. So then if I divide that, I end up with 17.786666 7. And that's in hours, obviously. Another way to kind of see that is to say that if I can cancel. So if there's a kilometres here and a kilometres here, they cancel out. But I'm left with the hours. So that's what my answer will be in. Now, to convert that into minutes, that means I just take the point 0.7866667, and I multiply it by 60. Okay, and then, so basically that gives me approximately 47 minutes. Okay, it's 47.2000. So, therefore, oh, that is the most terrible therefores I've seen. Oh, and it won't let me rub them out. Let's try again. Therefore, it would take 17 hours and 47 minutes to complete the journey. And you could probably say to complete the journey between points P and Q, which was our original question. So let's just do a quick criteria identifier. So up here we have our M1K1, our rule, our strategy. Down here we have subbed in, that's K2. Then we have K3 where we've calculated, C1 for making sure that we actually use units of measure. And then down here we've got a K2 and a K3. And then down here's our M3, our concluding sentence. Now, make sure you are copying down these examples as you go before you then move on and complete the worksheet that is Great Circles worksheet. After you've also done the small circles video and worksheet, you can then complete exercise 6.2, but start with just the worksheet, please.